What's going on, guys? Mr. Jones once again. Today, we're going to do one of my favorite tasks in all of Integrated Math 1. We've talked about this a lot as math teachers, and I've taught this lesson a whole bunch of different times. So this task is called Growing Dots. 1.2 stands for Chapter 1, Lesson 2. We skipped the first lesson because I don't like it. So with that being said, let's take a look. First and foremost, notice that it says it's a develop understanding task. That means it's going to be difficult. You're going to learn some new things, and it's going to be like patterns for you to try and figure out. And if you don't figure it out, don't beat yourself up about it, because I'm going to show you a lot of cool stuff, but you're going to want to have your composition book out and be taking notes of all the different things I show you. So have that out whenever you do this task. All right, first thing you're going to do, take a look at the pattern, the dots, right? You guys should see some dots. And because this curriculum is new, I just want to point some things out and slow some things down. You're going to want to pay attention not only to the dots, which are up here, but also the words at the bottom are going to be very important. Okay? So question number 1, like you can clearly see, and I'm going to have you just type this in Edpuzzle. Describe the pattern that you see in the sequence of figures above. Now, whenever you describe the pattern, I want you to be specific. Okay? How do you see the pattern growing specifically? In what specific way do you see it growing? All right. I wanted to show you guys the pattern bigger over here so I can draw on it for you, but hopefully you wrote some decent stuff and you got a chance to draw all over it, so you drew this on your paper, but it just depends how you saw it. Kids see it in multiple ways, and I want you to know that whatever way you saw it is perfect, okay? So an example is the way I saw it is, if you look over here at the 2 minutes, is I have this dot in the middle, right? This is the dot in the middle, and I think of that like as the body of like a table or of a four-legged creature. And that I have 4 legs, whether you think of it as a table or whatever, 4 legs to this table. And each leg has the number of dots that I see at the minute number. So here's 1 dot per leg, and I have 1 minute number, and this is the 0 minute number, and I don't even have any dots per leg, right? So that's how I saw it growing. If you saw it growing differently, that's totally fine. I wish I could hear about it. All right, so going back to the questions over here, the next question is, assuming the pattern continues in the same way, how many dots are there at 3 minutes? So on your paper, I want you to draw it and then go ahead and answer the question. Okay, hopefully you've had a chance to draw it and answer the question. And now I drew mine, so you can see that I have three dots per leg, and then I still have my dot in the middle. So the very next question now says, how many dots are there at 100 minutes? Now you really have to start thinking now. Okay, you really have to start thinking about, wow, 100 minutes is a long ways away, but what kind of pattern do you see? And how can you take the minute number that we talked about and the number of dots at each minute and relate that to 100? So at this time, go ahead and see what different ways you can do to figure that out and see if you can come up with an answer, and then we'll move on. All right, so I'm not going to give you that answer right away. What instead I want to do is I want to think about, I'll tell you what, I'll tell you the 2 answers that come up the most. One of them is 400, and one of them is 401. So I'll tell you one of those 2 answers is correct. So we'll get back to that here in a little bit, unless I forget. But the real question is, how many dots are there at t minutes? Now, what the heck does that mean? So that wants to know, like, for any number of minutes I can think of at 100 minutes, 337 minutes, 42 minutes, how can I figure out what do I have to do every single time? Okay, so we're really looking for some sort of equation. Okay, and if you have to type it out in words, that's okay. But if you can use an equation that says that the number of dots equals, and then whatever's happening with the number of minutes, that would be awesome. Okay, at this point, this says your solution should indicate how many dots will be in the pattern at 3 minutes, 100 minutes, and t minutes. Be sure to show how your solution relates to the picture and how you arrived at your solution. So at this point, see if you can't figure out a way how to do that. Also, if you guys have any idea how to make a table of values for this information, now is the time you're going to want to go ahead and do that. All right, go ahead, give it a shot. All right, guys, hopefully you've gone and taken a look at all this and you've tried to figure something out and even figured out an equation. Hopefully that'd be really cool. So what I want to do is I want to show you kind of the method that we're going to use for this type of equation, teach you what type of equation or what type of sequence this is, and go into a bunch of good stuff. So now is where the notes are going to be very critical. So please pay attention to the things that I write down. Okay, so first and foremost, let's go ahead and label what X and Y are going to represent so we know what the heck we're talking about. Okay, X is always the one that happens no matter what. Okay, so X happens no matter what. And that's just as simple as I can put it. We call that our independent variable. So no matter what means it's independent. Independent. Hopefully I spelled that right. It doesn't look like it, but it's all good. Independent. If you're an independent person, that means you do what you're going to do. You don't need someone else to tell you what to do or do things for you. That's what it means to be independent. And the variable that happens no matter what the heck anyone says is X. Okay, X, what's happening no matter what is pretty much always time. So this is your minutes. Okay, we can't change time. Time happens no matter what. No matter what we do, time always passes. Okay, your Y value, I'll put this in a different color. Let's use, I don't know, what is this, purple or something? Okay, your Y value is, it's called your dependent variable. This one happens, I'm just going to put dependent. Is it ant or ant? Let's try ant. Dependent. That's why I'm a math teacher. You could look it up and correct me in the comments. So dependent variable. And this one happens because of Y. Happens because, not because of Y, because of X. Because of X. So if this one was minutes, what happened because of the minutes? This is the number of dots, right? Your dots change based on the number of minutes. So hopefully I didn't confuse you there. But you're going to see these words come up a lot, independent and dependent. All right, moving along. So now that I know X is the number of minutes and Y is the number of dots, I can go ahead and put, let's use a different color here. I can go ahead and put my numbers here and I can go down as far as I want. So at 0 minutes, I'm going to put how many dots I actually have. So how many dots do I have at 0 minutes? 1 dot, because that's what at the beginning means. And then 5 dots. And then 9 dots. And then whenever we drew it, we had 13 dots, right? So this is always going to be a good strategy to make a table, by the way. All right, now that we have this information down, we can try and figure out like what the heck's going on every single time, right? Has nothing to do with the picture. We just have a whole bunch of numbers, and so we can find out what the heck the pattern's going to be. So let's talk about that. Okay, so most students can generally right away say, okay, Mr. Jones, we are just adding 4 dots every single time. Just take away all the hoopla of it and just say, cool, every single time over here, we're just adding 4 dots. dots, right? Adding 4 dots every single time. This type of sequence, where you're adding the same thing every single time, is called an arithmetic sequence. Okay, make sure you put this in your notes. This is important. An arithmetic sequence, okay, you're adding every single time. Adding the same number every time. So make sure you write that down. Okay? So we're dealing with what's called an arithmetic sequence, and the properties that we find out today are going to be the same for all arithmetic sequences. So back to the problem. We're adding the same thing every single time. And normally in class, I'd see if I can see anyone's equations, and we talk about those, and we talk about how they relate to the pattern. So instead of confusing everyone in this video, I'm going to do what I maybe shouldn't do, and I'm just going to show you how the heck everything is going to look. So we have the form of the equation. It's going to look very, very familiar to you. Okay, I'm going to scoot this over because now we just have these numbers, and I'm going to show you the form. So this is called the explicit form. Okay, make sure you write that down, explicit form. And this is how all arithmetic sequences look. They're always in this form. And the form is y equals, you've seen this before, mx plus b. Okay, and we need to find out what value goes here and what value goes here. There's two numbers that we're going to plug in, and then we'll have an equation that will work all the time. So here we go. I wish I can see your equations so we can talk about them. But I'm going to show you the equation. Y equals, and for my m value, I'm going to put it in purple. Okay. 4x plus, and then my b value I'll put in blue because I underlined it in blue. Oop, it's not b. The b value is going to be 1. So this is the equation. Okay, y equals 4x plus 1. It looks exactly like mx plus b in the exact same form. So my m is 4 and my b is 1. Now the question is, what the heck is m and what the heck is b? And where did those numbers come from, right? All right, let's talk about that. Y equals mx plus b. Make sure this is in your notes. Your m value is your common difference. That's what we call it. And we also call it the slope. So you've probably heard slope before. Common difference or slope. And where do we find that? Well, it's purple. Okay, it's purple. So I'm going to just go ahead and circle it right here. But this came from there, right? So these all go together. And I'm going to make a little arrow because that plugged in right there. So if you look over here in the equation, that is my m value. It came from my common difference and is going to every single time. Now my b value, this is my y-intercept. And I'm going to put my 0th term. Okay, that's what it really is. It's where x equals 0. So you'll notice right here, x equals 0 and y equals positive 1. So that's where this comes from. Should I put an arrow? Let's do it. Oh, there it is, looking good. So that b went there, and then look over here, it was positive 1. So you can clearly see that my m was 4 and my b was 1, and that was the equation. Now, what the heck does all this matter, right? So I'm trying to make some room on the screen so we can see everything at the same time. So what does this equation matter, right? Well, I think it matters because we want to know at 100. We don't want to make a table that goes all the way to 100. There has to be an easier way. And I think people started to realize, like, if you look at the picture, how many legs do I have? I have 4 legs of 2. So I'm saying the minute number of 2 times 4, right? Times 4. So, or the minute number of 1 times 4. So whatever the minute number is, remember that's your x value. So that's where the x comes in. So 4x stands for 4 times the number of dots you have in each leg. And the 4 is the number of leg. Plus 1 is the dot that's always in the middle. So that's us relating it to the picture. Now come back and relate it to the table. It's the exact same thing. You're adding 4 every single time. X is the number of times you're adding 4. So if I said 4 times 3, then that would mean I'm adding 4 3 times. And that's basically would mean you're at minute 3, and then add the 1. So how many are at 100? If I didn't confuse you enough already. At 100, you just plug in 100 right there. So really, I could put 100 down here for x and figure out what y is going to equal. So plug it in. Y equals 4 times 100 plus 1. Y equals 400 plus 1, and hopefully you realize the answer was 401, and that's a lot better than making a table with 100 values, right? So I just want to recap really fast. I know we just covered a whole lot of information. Okay, don't freak out. Let me just tell you what I want you to take away from this. I want you to realize that making a table is pretty cool. And we take the pattern in this case, which was plus 4, and we use that. That was very important. That was half of our equation. The other half of our equation was the y-intercept, or the value at x equals 0. So those are the two things that made the equation, okay? Another thing I want you to get from this is that this type of sequence is called an arithmetic sequence, and that arithmetic sequences are adding the same number every single time. And once we realize you're adding the same number every single time, then we knew we could use this form, right? So this is going to come up a whole bunch, guys, okay? Once you realize that the equation's arithmetic, because you say, hey, I know I'm adding the same number every time, then go, okay, where's my notes on y equals mx plus b, and what 2 pieces of information do I need to make that happen, to make that equation happen? All right, guys, I hope this helps. Have a great day.